Good morning, friends. Good morning, students. I'm back. Today we'll discuss glycine metabolism, right? So first of all, I will start with introduction to glycine. And first of all, it is non-essential amino acid, right? Second, it is optically inactive, right? And third is it is glucogenic amino acid, right? Now we'll start with the specialized product of glycine. Now the products are glycine is used for the synthesis. So first of all, it is involved in heme synthesis, right? And secondly it is involved in conjugation reactions, right? And thirdly it is involved in the synthesis of creatine, which will further lead to the synthesis of creatinine. And it is also involved in the synthesis of glutathione, right? And C4, C5 and N7 in purines is derived from glycine, and it is incorporated into proteins as well. For example, 30% in collagen there is glycine, right? Now we'll start with glycine formation, right? There are three things that can lead to the synthesis of glycine, right? The first is serine, second is threonine, and the third is glycine synthesis, right? So first of all, how threonine can lead to the synthesis of glycine by the enzyme threonine aldolase, right? So from 309 we can form glycine by 309 aldolase, right? And from serine we can also synthesize glycine by enzyme serine hydroxy methyl transferase, right? So, glycine can be synthesized from serine by serine hydroxymethyl transferase, from 309 by 309 aldolase, and the third is glycine synthetase, right? So we'll take carbon dioxide, right? Ammonium ions, right? And N5 and 10 tetrahydrofolate, right? These three together with glycine synthetase will result in the formation of glycine, right? To summarize, the three requirements, the three products that can lead to synthesis of glycine are: first is serine by serine hydroxymethyl transferase reaction, second is 309 by 309 aldolase, right? And the third is glycine synthetase by using carbon dioxide, ammonium ion, and 10 and 5 tetrahydrofolate. By glycine synthetase reaction, it will finally form glycine, right? So these are the three products that will lead to the synthesis of glycine, right? So now we'll start with degradation of glycine, right? So first of all, we have glycine. It will undergo reaction by glycine oxidase, right, to form glyoxylate, right? Now glyoxylate has two further pathways. First of all, it can form oxalate, right? The oxalate is finally excreted into urine, right? And the second is it will form formate, right? The formate will enter one carbon pool, right? And we can also resynthesize glycine from glyoxylate by transamination reaction, right? Reaction, right? So breakdown is glycine will form glyoxylate by glycine oxidase. Glyoxylate has two pathways. It can form oxalate and oxalates are excreted into urine. It can also form formate. The formate can enter one carbon pool, and glycolate can resynthesize glycine by transamination reaction, right? So if this reaction is blocked, right, there is no transamination going on, we will get disorder primary hyperoxaluria, right? Now we will start with disorders of glycine metabolism. There are two major disorders. First is glycinuria and the second is primary hyperoxaluria, right? So in glycinuria, there is increased secretion of glycine in urine. So the reason is there is effective renal absorption, right? There is directive renal absorption of glycine, so it will be excreted into urine. The patient will have tendency to form oxalate stones, right? The second disorder is primary hyperexuria. We discuss the transamination reaction is blocked, so the defective enzyme is glycine transaminase, right? So there will be increase in level of urinary oxalate, right? Now we'll start with specialized product of glycine, right? It is involved in these five major things. That is, it is involved in synthesis of glutathione, involved in the synthesis of heme. It is also involved in synthesis of creatinine. It is also involved in detoxification reactions, and it is also involved in conjugation of bile acids, right? So first of all, we synthesize glutathione, right? It contains glutamate, cysteine, and glycine, right? So glycine is one of the component of glutathione. It helps in maintaining the RBC membrane integrity, right? Now the second product is heme, right? Glycine plus succinyl CoA, right? With the enzyme ALA synthetase will undergo a series of reaction to finally form our second product, that is heme, right? So it is involved in the synthesis of heme as well. Now the third product is creatine, right? I will rub down here some glycine plus arginine, right? Will result in the synthesis of guanido acetate, right? Guanido acetate will further lead to the synthesis of creatine, right? Creatine will further form creatine phosphate and it will also form creatinine, right? Now the fourth step is detoxification, right? Glycine along with benzoic acid, right? It will form hypuric acid, right? So glycine plays a role in detoxification reactions as well. Now the final is conjugation, right? The bile acids, they undergo conjugation reactions with glycine, right? The five major things are glutathione, that is used in the synthesis of that maintain RBC membrane integrity. It is used in the synthesis of heme. It is used in the synthesis of creatine. It is involved in detoxification reaction with benzoic acid to form hydrochloric acid, and conjugation. Finally, bile acids will undergo conjugation reaction with glycine, right? So these are the five major specialized products of glycine. Now the final is therapeutic use of glycine. So it is used in prevention of heart disease, right? And it also prevents liver damage, and it helps in improvement of insulin sensitivity, right? And it also helps in induction of sleep, right? And some of these therapeutic uses are under experimental studies, right? So that finishes with our glycine metabolism. So please like the channel and subscribe the channel, and best wishes, keep studying. God bless.